Alright, let's back to our discussion. Oops. With a little trick, I do this. Okay, then oops. Like this. Okay, this is the value of x. So at the end, SO2 the concentration equals to NO2 concentration equals to x depth 0.0414, while the SO3 equals to NO equals to 0.1. Don't forget the unit, right? Like this. Don't worry, that of course there should be a acceptable range for the answer, because you can see I have used many approximations during the calculation, right? And here is. So for even more complicated case, so you can see at the starting both reactant get different number of mole, but don't worry, we can still do the job. With the given the value of Kc, I can handle it in no time, like this. And now it's your turn again, right? Okay, so you can see the gram and relative atomic mass. I'm sure you need to find the number of molar mass first. Okay, this is okay, given to you is 253.8. LICE. Well, this is the information given. With, okay, don't forget the value of Kc is 48. So now, let's start our job. Of course, it's minus x minus n. Don't forget this positive 2x because the coefficients. And the value of Kc is equals to 48. Wow, we have no other choice, just do the quadratic equation. And this is a good choice, okay, to see both value of x are positive. So which one I should reject it? And now, again, as I say, you should use your own chemical knowledge. At first, I only have 0.2 mole per dm cube of hydrogen. So how come I can lose 0.4, right? It doesn't make sense. If this one is possible, then at the end, both hydrogen and iodine's concentration will be negative. So this one should be rejected. Don't worry, in the public exam, you are not required to tell me why. You just write down rejected, it's fine, okay? So finally, the concentration of HI is mole per dm cube, and H2 will be I2 like this. It's a bit complicated because you need to use your own logic to determine which one will be should be rejected, right? But overall, I think it's still simple. Alright, so it's an interesting question for question 2. So please pay a few minutes to do it. Okay, I will show you the answer later. So do it now. Well, for question B, there is a point you need to mention. So what is meant by 0.5 mole per dm cube if a lower acid? So with the RICE again, well, this interpretation means at time equal to 0, the concentration should be 0.5. Well, this is the common expression. Okay, and you need to do the job to find this one. Okay. Okay, no, it's not question mark anymore, it's X. Like this. Yes, because you have some experience, okay, so I can go faster. And finally, so what is the pH is, okay, hope you still understand or remember the equation for calculate pH, right? finally is percentage ionization. Well, that means among 100 even lower acid molecule, how many of them will be decomposed? So what should I do is, so among 0.5 mole, there is only 2.99 times 10 to the power minus 3. Like this. There is 0.598%. It's less than 1%, right? Also, that's it. Alright, okay, so some of you may have looked at this one. Okay, so again, if you watch the video, so if got any questions, feel free to ask me in person or through WhatsApp, whatever. Okay, you are always welcome. Okay, finally is, so what if the equilibrium state is not attained or not reached? As I mentioned, go to equilibrium is you need some time, okay? But we have no idea how long it takes. Maybe within a second or last for thousands of years. It is possible. So how can we know if the equilibrium is reached or not? And now we introduce a term called reaction quotient, QC. The calculation of reaction quotient is exactly the same as Kc, exactly the same. The only difference is for Kc, you need to find the concentration in equilibrium. This is Kc, no problem. But the value of QC, you can take it at any time you like. So with this idea, okay, let's write down the same expression of Kc, but the concentration can taken at any moment. I don't care it is equilibrium or not. So there are three possible answers. The first one is both of them are the same. Alright, if yes, then congratulations, your system is equilibrium already. Or what if QC is less? Okay, QC is less. Well, if you still remember, the expression of Kc or QC is product over reactant. If QC is smaller, that means you don't have enough product, right? Not enough product. Well, that means the concentration of product must increase, and that the reactant must decrease. So that means there is a net forward reaction. Well, again, don't forget the term net is necessary. In the time going by, you will have net forward reaction to produce more product. Okay, so what about if QC is bigger? That is too much product, right? Then the concentration of product must decrease. And of course, or you can say the reactant must increase. So at the end, net backward reaction to produce more reactant, please. Alright? So the concept is very simple for equilibrium, for QC. So let's see how it works. Now, first of all, you are given all these species. Alright, it's easy. Kc equals to 0.74 square, 0.1, 0.1. Again, no unit, no unit. So next one is concentration suddenly increased to 1. Alright. Use reaction quotient to predict what will happen. Position of equilibrium means what will happen next. Okay, so if the QC, so is this one, okay, it's 100, which is greater than Kc, right? If greater than Kc, that means too much product. We got too much product. So net backward reaction will be expected to consume extra product. Okay, now here is a very special term, extra product. Well, this is necessary in the marking scheme, so don't miss it. Okay. All right. So this is. I hope you understand the Unit 39. And so again, if you got any questions, feel free to ask me in person or through WhatsApp, whatever method you can think about it. Okay. So see you next time. Bye bye.